Good morning everyone, I'm Kevin Cabrera and today we will be talking about the partial derivative. So today we will be having two different equations, which is the natural logarithm and the exponential function. Here let me show you an example. We got the natural log of e raised to the power of x to the power of 4 and y to the power of 5. Take note that we have two different functions, which is the exponential function and the natural log. And in solving those two, we must know the basics first in solving the different functions. In natural log, we only do the derivative of the inside and copy the inside. And as for the exponential function, we got the copy of the inside multiplied by the derivative of the inside. And if you ever came across with this letter, it simply means that it is fx is to y. But whenever we came across with dz over dx, we will only be solving the partial derivative with respect to x and treating the y variable as constant. Now we will be solving for the dz over dx is equals to, we will be following this kind of format. So since we got the derivative of the inside, we will be using this one, since the inside of it is an exponential function. So let us copy the inside, which is e raised to the power of x to the power of 4 and y raised to the power of 5, multiplied by the derivative of the inside. So we got, as stated in the power rule, we got the 4x and subtract the exponent by 1 and copy the y variable over the inside. So let's just copy the inside. E raised to the power of x to the power of 4, y to the power of 5. As you can see, we got this one in the denominator and this one in the numerator. We can simply cancel it out, so we can solve for our dz over dx, which is 4x cubed y to the power of 5. So this is our answer in respect to x. Now we will be solving for the dz over dy. So in respect to y, we will make the x variable constant. So do the same thing. We got the e raised to the power of x for y to the power of 5, multiplied by the derivative of the inside with respect to y. So we are making the x variable into constant, which is x to the power of 4, and use the power rule. So 5y raised to the power of 4 over e raised to the power of x to the power of 4 and y to the power of 5. The same thing still, we will cancel out this one in the denominator and this one in the numerator. So for our final answer on dz over dy, we got an x for 5y raised to the power of 4. So that's it for our partial derivative. Thank you and goodbye.
She calls me day and night. I'm sorry, girl, you just don't make me feel right.